hope that it will stay with us. Um, and I will try to share with you this notebook afterwards. So I'll use 4 packages that are not the packages that everyone has it's just able to send API calls, some requests, and I see the information here. And now I want okay. So does it work? I cannot. I mean there. Okay. Okay. Good for the recording. Okay. Okay. Okay, it's recording. Okay, so actually earlier, and I will show you that in a bit. Earlier, I went to YouTube. I found a video that shows like a dialogue between a customer and a representative in a bank, and I have downloaded that. And I would like to make the large language model to analyze it. So to do that, you have to give some instructions to the model about what you want to do. And as we know, like the new programming language is like English, so you can just like write here the instructions. So according to my goal, I tell it like you are an AI assistant that can understand the discussion in the call center of a bank. The input is a dialogue between the customer and the call center representative. And here you say it's going to be the input. And you have a couple of tasks. So most audio to text models are not very good. I mean, they are quite good, but if you see like the text they give, it has some words that are not properly spelled, especially if they are of a specific terminology. So you can ask the large language model to do the first thing. If there are some nonsensical words, convert them to the most probable real word, taking into account that this is a transcript from a customer representative discussion at a bank's call center. And second, convert the text into a dialogue of the form CR, where C customer and R is representative of the bank call center, and use your judgment to distinguish between the two roles and who said what. And output this dialogue. And here is where we actually use this LangChain. So these commands here come from LangChain. And I say, OK, I use this prompt that I get this template, and it will have some input that we will give. And then I put a chain, and that's why it's called LangChain. It's chain of language elements. So we combine a large language model, GPT, ChatGPT, with this prompt above, and we say verbose false pretty much. It's not going to show us all the thoughts behind it. So if I was running that with any input, and let me see if I can do it without making a mess, like chain dialogue. I will try. Hi, how are you? Good, I'm fine. Bank, whatever. Let's see if it's gonna run. Oh, I haven't run this cell. Okay. Okay. So it realized that it's not perfect, but says like customer, how are you? And representative, good, I'm fine. How I can assist you today? So it does something, but then you'll see it in action actually. And then I will introduce a second prompt that again takes the same input, the dialogue between a customer and the call center representative. And now I say it has a couple of tasks. Again, correct whatever words are not there. But this time, I ask it to do something more useful that will be more useful for real-world applications. Extract information from the whole dialogue. So it will get the full transcript, and it will create a short summary, and also will find the following from the dialogue. The bank account number, if mentioned, the social security number, the last 4 digits, if mentioned, and the first and last name of the customer. And the output should have like a formatization file if you want to save it somewhere with these entries. And it's, again, the same format. I take this prompt, these instructions, I combine them with LLM chain. Okay. And now I'll do the second component. So we have worked, like we have created those tools that will allow us to process some text that is, it's a transcript from a audio model and get some structured form. But then we need actually a model that can perform automatic speech recognition. And an easy way to do that is to get this pipeline from transformers, it's from Hugging Face. I would be happy to explain the steps later if you want, like where each element comes from. And if you just like write this, it will automatically download like a model from Facebook that is called Wave2Vec2 that is able to do some transcription, like you talk, and it creates, it creates a transcript, but it's not super perfect. Okay.
What is pipeline?
So the pipeline here is, first of all, download. Like when you write pipeline, it downloads everything in your computer or on your local machine, as you said, and it has the audio model together with things like tokenizers, like how it represents words into vectors. So there are a few things that, if you wanted to be more careful, you could go and specify. Yes? What? Oh, I say, yeah, I mean, I'm not sure here. Here? Yeah, I mean, I'm not sure if that actually prevents it from hallucinations. Hallucinations, like for people that are new to generative AI, is when you ask something, like you don't have any information in the text that you provide, but it gives you something. Like if you ask for a social security number, sometimes a large language model, if there is no number around, it will create something. If you don't have a name, it may create a name. But in this case, I try to avoid that, and I think that it works in most cases. It doesn't create new things. Okay, so this was a fake audio for text. So the last thing that I will write is a function. We can come back to this a little bit later, but for now is that once we have an audio input, it will get the text. It will run it through these two chains that we described above. One that is the dialogue, and one that extracts information and get output like the summary, the account number, the social security number, first name, last name, and output these here. And then we can create a small interface to actually play with it. Now, I can come back and explain the interface in a bit, but it may be more interesting to actually play with it. Okay, let's see. Let's see the large language model and the audio model in action. Let's hope it's going to load. Again, I use my phone Wi-Fi. Okay, so transcriber. Okay, so here we have our interface. If you want later, we can do with a real, like in a live dialogue. But for now, let me just get an audio that I created earlier, submit that recorded to be processed, and you can listen it. let's see, this is still running. I don't know if it's a good sign. Earlier today it was taking about like a minute. I don't know why it's so slow now. Oh, what is the station input? What is the problem here? Yeah, this is a transcript. No, this is not. Yeah, also transcribe. Let's see what is the problem here. Let me see something. Search microphone. Let me do something. Yeah. I mean, this, it should be already saved, but yeah. Yes, so I can explain a little bit this Gradio, the UI. So, of like once like it's good to kind of design it somewhere, and like when you try to make it, but pretty much like it allows you to create the title that you see here, and then it has like a way to write the title with a markdown, and then it has this audio that allows you to get like either from the microphone or from the like from an audio file, upload your audio, and then when you submit, it actually sends the recording to this function that I defined above that is being processed in this transcribe function, and then you have these buttons like for the outputs, like for the account number, so you arrange them with some rows and some tabs if you want. I can explain that a little bit. But let me see if it works something here. So with recording. Hello, how are you? I'm fine. What is the problem? Oh, I have a problem with my credit card. Oh, I'm sorry to hear that. Yeah, let's see if that short thing is going to work. Oh, it's gonna have a problem again. That's not a good sign. End of JSON input. Let me run it with this fake audio. So, okay, one important thing that one can do in these cases is to debug. So in these cases, I just have some fake text, and I can run to see the output of this. Okay, this looks fine. So I'm not sure why it doesn't do the transcription. Okay. Hi, hi, how are you? I'm fine. I'm working for a bank. Let's see. End of JSON input. Summary. I don't know. I mean, that seems to be the case because when I give a fake audio, well, Yes, it's already taxed. That's what I'm saying. Hmm. Most probably, but sh- yeah, let me see. Okay, let me find again. What is that? Like, just in case. Okay, one last moment, one last trial. Uh, just in case. I have, yeah. Yes. Let me see with that, but is that the problem for on Colab? Let's see. Yeah. Okay, yeah, let's see that. Hello, hello, hello. One, two, three. Test. Oh, okay. Let's see. Okay, let's see if it works this time. So, okay, in this case, I will say upload. Upload. Let's see if it works. Okay. Okay, bank customer. Submit recording. Let's see how much time this is going to take. It should take about a minute. We want to hear it again. Where did they find what? I know someone told me that they have to put share equals true, but I'm not sure if that's a problem or something else. Or it may fail again, who knows. Come on. Oh. Uh, okay, I don't know what's going on here. Text, audio. Of the LLM, let me see. Yeah, I tried with the fake text. Yes. So yeah, yeah. Let me do this thing with a fake audio. File chain info. It seems not the correct. Hi, how can I help you today? What's your problem? I had a problem with my credit card. I lost it. Oh, what is your social security number? 334. Let's see. Oh, okay. Well, I don't know. It was working earlier today. I promise.
Yeah, so what we can do, Demetrio, is you'll share the notebooks, right?
Yeah, I can share the notebook.
Yeah, so once you fix it, you can share it, and then you guys can try it out, right? I
Yeah,
would like to try it out too. Yeah, yeah.
yeah. So, yeah, I don't know what happened here. So let's,
Live demos are always risky, right? So,
yeah,
I think if you could give an overview of what yeah.
yeah,
he was trying to do right now.
yeah. So, okay, yeah, I suppose I will share it another time. I promised it was working.
We've all been there.
Yeah,
Everybody's been there. Don't worry.
okay. So, where is the second presenter?
Explain what it was supposed to do.
Okay, so it was supposed. Okay, let's. While I'm explaining, let me restart and run all, and maybe it will. It will. Maybe it will work.
So it does it just kind of take the transcript and then
So yeah. So what it does, it takes the whole transcript, and if you see the raw transcript, it has some problems. Like some words are not clearly spelled, uh, and so first it corrects that. Usually, like most words are converted to real words. Second, creates a summary. So if you come here, and if it was working, first you would have the original transcript, and it would be able to distinguish between what was said by the customer representative and what was said by uh, the customer, the call center representative, and what was said by the customer, and also extract some information that in theory someone could use to automatically save it in the system, like a summary that describes what was the main complaint, let's say, or the main problem that was faced by the customer, and information like the social security number, the account number, name, and surname, and you can think they are like that you can extract automatically any kind of information that may be interesting for your application uh, uh, using the large language model. So the large language model is able to just like get a whole chunk of text and find the information without having to, let's say, for people that are familiar with other natural language processing, you have to train a model for the specific task. If you wanted to find like summarize something, you have to train a model for summarization or for extracting some information. Here, you just like tell to your large language model what you want, and it finds the information itself. So that's why it's powerful to combine an automatic like transcription model with a large language model. So let's do a so for it's this model by Facebook called Wave2Vec. Yeah. Oops. Yes. So behind the scenes, how this thing works is that like Google has not Google, like Meta in this case, like comes from Facebook, has a model that gets the audio file that has like some waveform, and they know like based on how this waveform works, they have trained a neural network that this, like for example, this corresponds to the word like cat. So, but sometimes this is not perfect, like especially based on based on the accent, especially or oops. There are differences, or if the word is not very common, it may create some errors. So this can be corrected by using the LLM in principle. Let's see though. Yeah, Whisper is very popular. It's very good. So to run Whisper, I have run it somewhere. Yeah, I have. Whisper requires like to run it. You have to have GPUs, so you can do it on Colab, but yeah, it's a better model for that. Let's do the final trial, and if not, well. So. Like, okay, last 1 minute, and if it doesn't work, it doesn't. Well, let's see. Yes?
Maybe while it's running, maybe continue the diagram on the board. This is really helpful to understand what it's trying to do.
Yeah, so, okay. Let me see. So this is the audio model. So the audio, for that case, it would say something. It will say, the output would look like something like, okay. It will be, hi, how are you? My like it may have some number is 5, 3. Sometimes, for example, the 3, it can think that it's 3 and not 3. 6, 7. So, great, thanks. And it's like a continuous thing usually that doesn't distinguish who said what. It makes errors like this. But if you say to the LLM that this is, a bank customer call, for example, it will probably convert this 3 to the correct word 3. And also say that the how are you was called by the representative, and this was by the customer. And this is something that the LLM does. Like the original audio model cannot do. Okay. Well, this doesn't work for some reason. Yeah. Well. Yeah, I mean, unless my credit card is, it's totally, well. Yeah. Well, what is? Let me see. What I had in the past. Okay. I'll check a different model and let's see if that is going to do the work. Yeah. I have, but I think maybe we can skip it unless there is.
No, we can go to that and then come back to this if it works.
Do we have time? Because that one should be pretty long.
Yeah, I think that'll be nice. You can switch to the other one.
Okay. Uh, okay. Okay, I'll submit that, leave it running, and let's see if it's going to. Uh, okay.
Yeah, let it run and then you can switch back.
Okay. So now that's the fun math part, kind of. So let me think. Let me see. Okay. So how many people are actually? Oops. Okay, I cannot erase this. How many people are actually excited about math? Yes. And second, like, is everyone familiar that the tool behind behind like ChatGPT and all these things is called like transformers, and the attention mechanism. How many people have followed this paper that's called Attention is All You Need, and the math behind it? So I thought like we can a little bit like explain the math behind that and the attention mechanism in a way that I found easy for me to understand. Like transformers are behind like ChatGPT, DALL-E, they are foundational models, so it means that you can train them for like general language understanding and then fine tune for specific tasks. And what is behind it is this idea of attention that for some tasks, like for example, imagine that you want to predict the word apple, and you have, not you predict, like you want to generate what, like assuming that you don't have here the word apple, if you see the word eating and the word green, it gives you more information that this word here should be apple compared to seeing like the word is next to them. Like, so the fact that in this sentence you have the word is not giving you so much information that here you should have apple, but the words eating and green give you more information. So this is what's called high attention. So if you want to find this word, you should pay more attention to eating and to green than the other words. And also, like, assuming that you want to classify this image and say if that is like a dog or if it is a cat, probably you have to pay more attention to these areas than these or to the blanket. So this mechanism that is behind transformers is somehow motivated by how visually we pay attention to some areas, or when we want to translate or find what is the next word, we pay attention to some specific words in the sentence. Okay, so here is like the math. And I will start with a very simple basic form of this attention mechanism, so half of people can leave. As you know, computers and deep learning cannot understand words. Like if you want to put this sentence in a computer, you cannot put that, but you have to have, for example, for the word eating, you have to represent it as a vector with some numbers here, blah, 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 blah. So one idea would be to get all the possible words, or like, let's say, 100K words, and have vectors that have dimension 100K that have 0 everywhere else and 1 to like at the position of that specific word. But that wouldn't be very efficient because you would have to make operations with vectors that are pretty empty everywhere except in one only position. The other way is to try to represent, that's a little bit weird here, with smaller dimensions, for example, 50, and have some numbers. But how do you select these numbers? So actually you can try, not you can try, you do. You use a neural network to learn some numbers, such as to create some meaningful things, like you create vectors. This is a famous example maybe people have seen, that if I consider the vector king, like whatever representation is, minus male plus female, it will give you queen. So this is kind of example that people see everywhere. So imagine that you start with some vectors that have such kind of like representations that have some meanings. How do you construct some new vectors that take into account which combinations have higher attention or lower attention? You want things that this combination contributes more than, let's say, this combination. So that's what attention does in mathematical form. You start with these word vectors, and you create new ones, wise, by summing all the vectors in your sentence with some weights. And these weights are just how similar the words are. So in this case here, for example, the eating with apple will give a high W vector there, while C and apple will be small. So pretty much you will end up with some new vectors that keep only the combination of high attention. Okay, and pretty much that's it. The whole thing behind transformers is just this small operation, and everything else is just some comments on that. Because you can see, for example, that the way you form these vectors, once you have some initial vectors x, and you calculate this matrix, these weights, with the product of these vectors, it's what it is. Like, you cannot change anything. Yes?
So what is your n?
What n?
Yeah.
Where n?
You're summing over
Oh, say.
from 1 to n.
Okay, so this is all the words in the sentence. Or let me see. Like, okay, so you have some batch of words. Like, imagine if you have a long text, you select this T. Actually, this runs from J to T. Yes. So you start with a batch of words. I think this is like, something like 528 or something. And this is like a batch of words, or, tokens. that you start. And each one of them has like a D embedding dimension that I described earlier. So this is the whole attention thing. And that's all, and that would be all, so we could go back home. And it wouldn't be a machine learning method because you don't have anything to learn. Because everything here is already calculated, like some product between how like the words are more similar, and that's all. So what people thought is that if you see this x appears 3 times, like if you put this back here, you have this xi 3 times. So the idea is, OK, let's define these query key value vectors by just multiplying these vectors by a matrix that you can forget about all these dimensions, etc. But the idea is that now I have some weights I can learn in a standard machine learning way when you try to find the best weights for your problem at hand, like the best numbers. So you just generalize what I showed you earlier with the attention by introducing this like matrices of learnable weights, and everything else works exactly the same. But you can have now an algorithm, for example, gradient descent, to learn the best weights for like your problem at hand. And maybe we can see, like, since discussions were mentioned, like if you put these in matrices, that you can say you create this attention matrix here that captures these correlations. Like, for example, in the small expression, the garden is blooming, the correlation between garden and blooming is higher compared to the correlation between garden and is. So this extracts the important correlations for the problem at hand, multiplies with this value matrix, and this is what is called the attention, and that's all. So it's pretty much a way to capture the important correlations. And OK, for a problem, for example, for translation, you can have different important correlations, like especially if you have more complex sentences. So in some cases, the correlation between garden and blooming it has some importance. In some other cases, like for another type of translation, this correlation may not be the most important one. So people have here, like for the dimensions, maybe. Like, so this could be, OK, t has to be, yeah, the same. Yeah, OK, we can rotate it. Yeah. So people put many of these things side by side, and if you do all the math, the idea is that you pass it through this kind of attention many times, like 8, for example, in the original paper. And the whole thing is that actually you don't really have to pay too much attention to all this weird math. Is that the whole point is that you started with t words of some embedding dimension DE, and you ended up having something different. The same number of vectors as the original number of words, but with some new embeddings that now have captured the correlation between the words or between the patches of images, let's say, that are important for the task, like translation, like predicting next word, etc. Yes? So originally, they are learned from like large corporates. Like these are, for example, if you have here the word-to-vec model trained by Google, that's like learns representations from like large parts of text using a neural network. The difference between these and that is that these are like learn generally like what is the correlation between queen and king. But if you want to use this model for translation, maybe the original vectors has to change a little bit for the specific context of your work.
The idea for attention that we start with an original embedding vector.
Mm-hmm.
Transform it into a domain-specific representation.
Yeah, for the task at hand, like predicting next words, like translation, etc. So this is the whole idea. So I'm not going to go through all the math, but the idea is that you start with some t times d initial embeddings, and you end up having some different embeddings that have been learned in a way to, like trained in a way that are optimal for your machine learning problem. So the multi-head attention, the way I understand it is like the multi-head is like you do that multiple times, and why? So imagine that there were like 10 words for your problem, having like the one case this correlation is like 0.9, but also plus something that the correlation is 0.7 plus something else. It's more flexible. So okay, for example, for people that have seen how convolutional neural networks work, that this is similar to the filters in convolutional neural networks. So in image recognition, you have these filters that, let's say, capture, some of them capture some, like in this direction, some features, or like people may say, okay, like when you try to recognize a cat, one filter may pick ears, another filter may pick the nose of the cat. Imagine something like that, but with the words, for example. Like in one, it captures what is the important correlation for one task, some other important correlation, so extracts different patterns, and that's why they have multiple heads. It's pretty much like the same way that for a cat-dog classification, you may want to capture in one filter that finds ears, one filter that finds noses. Yeah. Okay. So yeah, I will probably skip a little bit because I have, I know it's kind of tiring. But I want to show you that also recently, like the same thing that started from natural language processing, it's also applied to image analysis. So in this case, you start with an image, you create some patches, you flatten them as vectors in the similar way as you do for words, and you use exactly the same mechanism to find which correlations between patches are more informative for a classification problem, for example, which is similar to what we saw at the beginning. Like, for example, the correlation between this patch and this patch is important to classify that this is a dog and not a cat. And since I come from the astrophysics domain, I'm not sure if I said that. For example, this has been applied like lately to classify galaxies between if they have, like you see here, cigar-shaped or edged-on or irregular or round galaxies. And these seem to give results that are very close to the best performing convolutional neural networks that used to be the state of the art in the field. So it's also like an upcoming method. So I'll stop here because I think it's a lot of information, and let me see if that has given anything. Oh, it still gives errors. Okay. Well, so I'll try to solve it and send to people. Okay. Any questions? Okay, see, it's getting late, so.
You'll be sharing the presentation.
What?
You're going to be sharing the presentation.
The notes, like.
Yes, that.
Okay. Yeah, I'll also send it to the organizers. But any questions?
So, yeah, one question is, you had an example from a call
Yes.
extracting, improving the transcription, summarizing it, extracting out key concepts, you can put those in the database. I can imagine, that'd be
Yeah.
useful for improving the quality of your call center experience.
Yes.
What are some other things that you think that your organization or others could do with this that would have
Yeah.
a really big impact?
So, okay, I suppose I shouldn't say that, but because there are so many startups doing the same, I will say, like, for example, it's very, there, yeah, hundreds, like dozens of startups that try to automate the clinical note taking. Like when doctors want to type everything in interaction and then go and create specific type of notes. That's like very popular application. Many startups out there that they, like even Amazon is part of it now, like automatic transcription and note generation for doctors. In the domain of combining audio and text. Now, if it is just text, generally any like search on text databases, like a large chunk of text and extract specific information. Yeah.
What's the next one? That's a good point. So if you want to videos, what do you recommend? What's the how to
Like add like searching on video. I mean, there are models that work with both video and like images, but I don't have much experience for that. Yeah.
Can you say anything about prompt engineering? So
Yeah.
does it matter, for example, so here what you told us, thank you.
Mhm.
This is how the transformers work on the back.
Yeah.
This is how you are training. That's what happened when we are training the model.
Mhm.
You're already downloading if you use open source.
Yeah.
So that's what you told us is actually the training will
Yes.
modify the factors. What about the prompting?
Yeah. Prompting is actually this thing here. Like when you actually instruct, like give some specific instruction to the model. So to kind of make a connection to these transformers that I described is like the prompt, it pretty much helps the model to get like from all these different weight combinations to grab those that are more specific for the problem at hand. Yes. Like, because yeah, it's like words, but behind the scenes it's just math. So the way I imagine the prompt engineering is like from all these possible combinations for the same type of words, you kind of steer the model to just like because you know that these have like hundreds of billions of weights, to just keep those that are more appropriate for the model. Like if it is a medical dialogue, you say, okay, you will receive something that may have words of medications and symptoms, and pay attention to that. Here you say, oh, it will be probably bank account numbers, so pay attention to that. And this is the prompt engineering aspect. Yes? Sorry? Private data, like our data, or not to the Wave2Vec, because this one runs locally and you don't share anything.
It doesn't run locally.
No?
Uploaded your data to OpenAI.
Ah, to the OpenAI, yes. Not to the AudioMile file.
Your data to OpenAI. There is open source option.
Yes.
Sorry.
No, it's true, it's true, it's true. But like it was not in the audio model. I say it was like in the LLM model.
So the solution is to run open source or something locally in your server. But if you do OpenAI, to my knowledge, you're actually sending the data there. However, I know there's a promise that you're not going to have to charge. This thing is super. Whenever you give your data, you're exactly what you have your
Let me see if there's water.
Azure are going to be Microsoft Azure.
Is there any water? Yes. Yeah. Yeah, whatever. Because after all this.
Yeah, of course.
Ugh.
Do you want to take a break now? Tell everybody to
Yeah, yeah. I don't have anything else like to share anyway. I mean, I can try to check.
That's fine. I mean, because we are already so late, and
Yeah.
and then if you're almost done, then
Yeah, done.
I can spend 15 minutes.
Yeah.
That's all. That way we don't keep people too long. And then and then folks, if you like some pizza, we have some extra additional.
Ah.
There is pepperoni here.
Yeah. So yeah. Sorry, I just.
Not super well, but
Yeah.
some soda.
Yeah. Let me. Yeah. Sorry, it didn't work. Now, now you know that it will work. Like, I'm pretty sure that now it's been 5 minutes and it's going to work. Because that's how it goes.
Beatrice, would you be willing to share a video of the demo end to end?
Yeah, yeah.
I think that'd be great.
Yeah, I mean, except the part when I have my OpenAI key, unless I start receiving like something like.
Yeah. Okay. Oh, I can't believe I'm actually supposed to speak. I ended up doing hosting. And then
That's your turn.
the pizza lady kind of got the address wrong. So we're waiting, like, where is she? And she was up in East Wacker and not South Wacker.
I see.
And then there was traffic problems, so it took a long time. Finally made it to the but there are no plates or cups. We found a couple cups, yeah, for the soda. But sorry about that. It's like a very weird night, kind of things are not working.
Oh, source.
Mary, where's your last name from?
Oh, it's Polish last name, but it's not mine, obviously.
Why
Yeah.
obviously?
Yeah. Well, it's my ex-husband now, so yeah. So that's why. Yeah. You wouldn't think I look Polish or something. Are you a Polish heritage or? You are Polish heritage? Oh, okay.
So I was like, wait, I think I'm pretty sure it's Polish. It could be.
You are right.
Could be like Czech,
It
but
is.
most likely Polish.
It is Polish origin. Yeah, that's for sure. Yeah. And how about yours?
What is your origin?
I'm sorry, my
What is your origin?
origin. Oh, I was born in Hong Kong and grew up there. So yeah, Chinese. Yeah. So you are both Polish? Or? Oh, okay. Yeah. Are you from Poland?
Yes.
Oh, wow. Yeah. So are you now like working with?
We live in Chicago now.
Oh.
So we moved to Chicago.
Oh, from.
5 years ago. 17.
Are you from Krakow area by any chance?
Near Krakow.
I love Krakow.
We did?
I will be going there in the last week of October
awesome.
again. Yeah, I was there for a
nice.
conference too,
That's really
like DevOps Poland and Krakow, and then also a GeekCon or something. I was in Krakow for like 5 times so far. I feel like I know the place well, and I love the Wawel Castle. I love it. I love it. So yeah, it's my favorite.
Glad you had a good time in
I
Krakow.
love it. I look forward to going again. So yeah, that's right. Yeah. So yeah.
Beautiful old style European city, yeah.
Yes, yeah, I love it. Yeah, I love it. So yeah, that's right. Yeah, so okay, yeah. If you feel like some pizza, I think there may be some more too.
I'm too fat.
Oh.
I think we've been eating pizza every day.
Oh.
Yeah, we had pizza yesterday.
If you have an end-to-end video as part of the GitHub or whatever it is. There's so much good information.
I can certainly share it, and I have also going to work. Like when people try to there.
It's gonna work. This time, I feel it. I think you have to sacrifice chicken or something to
Yeah, amazing radio, good lunch chain.
Do you like Lane Chain?
I some people at work were trying to say, oh,
Że będzie w domu 9 coś?
right, everybody knows that. But then that made like, you don't have a community. Like, when you find a problem with that chain,
Bo Helena ma w domu, jak ona jest wolna w pracy.
yeah, about something, yeah,
Teraz
exactly.
jest w pracy, bo musi zostać z tym, z dziećmi.
It's getting
Utknęła trochę.
No i tak dzisiaj tak
No ale odebrała klucze dzisiaj, pojadzie dzisiaj dopiero wieczorem. Nie wiem. Może chce jechać do córkę zabrać. Dlatego mówię, pewnie około. So I took the keys and they were with the car keys. And I took the keys to the car place and I'm giving the guy the keys and I realized I'm like, I give him the keys. In the glove box there's the address. It's all the house keys and everything. I probably shouldn't do that.
That
So I
makes
took the
sense.
keys.
That makes sense.
I figured I would just give her the keys at her job because it's so close to us, you know?
Oh, yes. Are you a data or AI engineer?
So I'm using it right now.
Yeah, yeah.
I mean, it's standard issue.
Yeah, that's right.
yeah, I don't know. Yeah.
That's Shelly-Ann is from the New York team, she's in Ohio. One of the top producers. I think you met her.
I mean, that was supposed to be.
我感觉不觉得不觉得。
It didn't work out.
回家是的，你好，你不觉得？Yeah. Gym mix, right? It's important to me.
Mary, will you be presenting today?
Yes, I will be.
Oh, you will
Yeah,
be?
yeah, I will be. Yeah, yeah, yeah. I was supposed to go first, but I was like bad traffic, got here late, and
Waiting for your presentation.
oh, thank you, thank you, thank you, thank you. Yeah, so hopefully mine are more introductory than
Yes,
overview.
that's exactly.
Yeah, because I figure, okay, even I'm like new, I'll explain too. But even I'm new, because I was more working on other things. But this also helps me when I talk about it. I'm also educating myself. So,
Of course.
Yeah, yeah, yeah. So yeah, yeah, yeah. So thank you, thank you for your support. So yeah.
Oh yeah, sure. I'm gonna go run through that.
Oh, sure. Thank you. Oh, because it was like this, it bothers you. Thank you. Oh,
Nie, to
yeah.
nie będziemy
I mean, I
wtedy
would
jedli.
too. Yeah, I didn't pay attention. Yeah.
supposed to, but then like Dimitri was ready. I said go ahead, and because I just got here, so I suddenly swapped. Yeah, I should say. Yeah. But yeah, then I have to help out with all these other things, right? So sorry about that. I should be able to start up pretty soon. So is a developer advocate. So yeah, so I kind of go out and talk about technology, what our company has, and all those things. Yeah. So yeah, more knowledge sharing type of role. Yeah. So yeah, that's right. So we should be able to start pretty soon. Yeah, so for me, mine will just be really quick now because there's also like so much distraction. I don't feel I'm like ready. But the thing is, I still want to introduce mostly to about our vector database. That's the core. But I want to also bring in, like concepts of all of these Gen AI things first and some history. So a bit more general talk and then get a bit into vector DB and wanting to show you. But right now the problem is there's no internet, so I'm just using my hotspot. If it doesn't work, it may not work as good, but I want to at least share with everybody how you can try out our vector database, for example. Yeah. Are you already working with data science or? Okay, yeah. Sure. Yeah, it's more introductory. Yeah.
Small place, but
All right.
Really thought it
we
through.
have a box.
Sure, please do. Yeah. Maybe we can start up pretty soon too. Yeah. Yeah, that's right. And your name? Maggie. Okay, yeah. You go to school here at U of Chicago? Or? Oh, okay, nice. Very nice. Yeah. Oh, great. Yeah. Okay, great. Okay, you are. Okay, yeah, cool. What is your name? Yeah.
Maggie.
Maggie. Okay, yeah.
It's actually Magdalena. I never use it.
Oh,
I go by Maggie. And I sent you a LinkedIn
Wonderful.
connection.
Yeah. Are you working with data science right now too?
I'm an IT project manager.
Oh, okay. Work in Chicago, right?
Yes,
Yeah,
I work in Chicago.
Oh, okay. How about you? Are you also IT project manager or maybe more engineer? Sorry, I caught you.
Neither.
Oh, okay.
I'm a vice president of sales for
Oh,
life insurance company.
Oh, I
My
see.
background's finance
oh, okay.
and data science in school,
Oh, okay.
and so I'm trying to see how I can incorporate it too.
Yeah. Okay. Sounds good. Yeah, wonderful. Yeah, wonderful. That's great. Yeah. All right. Yeah. Okay. Yes, we should start now. I was going to say, sorry, but let's chat afterwards too. Let me get Ron to start.
Absolutely.
Yeah.
Patrick, używać ChatGPT też. Musimy mieć hasło do GPT-4, granie pracuję bym chciał używać. Bo ja teraz mam stronę, co płaci za artykuły i ChatGPT bez mnie nie pisał. Ja będę tylko edytował na lepsze. Bo czemu jestem ekspertem we wszystkim.
Okay.
Jak więcej pracy.
That makes sense.
Płacą za dobry artykuł, płacą 600, za bardzo dobry płacą 900, za średni płacą 200. Artykuł jest 5000 słów około.
Ja się sprzedał
Godzinę na
nasze weby prompt.
Ja?
To wszystko zależy od prompt.
Nie.
Ja nie robię weby prompt.
A, to możemy posiedzieć, bo ja robię bardzo dobry rap.
Ania. Unfortunately.
Okay, let me make sure. Yeah. Gotta make sure I mute it. Yeah, okay.
Okay, guys, we're gonna restart.
Yep.
Very gonna do the next presentation.
Yeah, that's right, yeah. When you get ready within a minute or two. So, woo! Thank you.
Get your pizzas, let's get back to the
Yeah.
next presentation.
Yeah. All right, yeah. So,
Do you have the...
oh yes, I need this right in order for you to catch it. Should clip it. Okay. Is it already on? Okay. You got it? Can you, is it working for you? Okay, great, great, yeah. Okay, all right. So, yeah, so again, welcome, thank you, everybody, for having stayed this long and then waited for the pizza. I hope there's enough now, and at least you're not hungry. So, and a bunch of people already left, so I feel kind of bad. So I promise, I think we'll work with Bill to get this more smoothly next time. And again, you know, thank you. Yeah, we'll fix it. We had no idea. So yeah, the first of all, Bill didn't even come. So it's kind of hard. I'm like trying to talk and trying to host it. Thank you again for Svetlana for helping, and thanks for Dimitrios and for Ron. So, okay, so actually, before I start may I ask, first of all, how many of you are already working with Gen AI in some form or another? Oh, okay, all right. So are you working mostly from a data science perspective or maybe engineering? You're data science and not so much like engineering or maybe operational. Are you on that side, or maybe a mix of things, right? So just a few. Okay, so how many of you, let's say, right, you're already working, how many of you are already working on evaluating and trying to shop around or maybe determine what to do with a new project? Yeah, so a few. Okay, and how many of you are familiar with it but just kind of tinkering around, right, so to speak, you are interested? Okay, so a few. And how many of you are really new? Kind of completely new, yeah, like, yeah, to this, to Gen AI specific. Okay, yeah, no problem. How many of you are actually students too, may I ask? Okay, so quite a few. So you are also data science, right? Yeah, okay, all right, that's good. Okay, so I'll just start with this, this talk now. Essentially too, I call it Enter the Brave New World of Gen AI, yeah, because for me too, it feels like that too. Okay, so I'll give you a bit of a background of myself and who's Mary, right? So I'm a senior developer advocate at DataStax. How many of you, first of all, are familiar with DataStax or heard of? Yeah, okay. Are you working with Cassandra? Like anybody, Apache Cassandra, the NoSQL? No problem. And then how did you know about DataStax, or what do you know about DataStax? Just randomly. Okay, yeah. So, okay, so just a quick thing is Cassandra is the company's kind of bread and butter. Apache Cassandra, that's the NoSQL database, much like people are talking about MongoDB, kind of like that, but we have our own. And just a real quick thing, Apache Cassandra is really robust too, meaning that it is a kind of peer-to-peer type of clustering NoSQL database. So it's very robust. And if I cite examples, Apple Computer, in their data center, they all use Cassandra as their database engine too. So it's all, you know, replicated, and it never goes down too because of this architecture. And also like linear, they call it what, because I didn't advocate for Cassandra, I was more working with event streaming with Kafka and Pulsar, so it's different. So my company, okay, 2 months ago decided we're gonna switch direction to doing Gen AI. And then specifically with Cassandra, we added in vector data type. Are you familiar? Anybody working with vector database? Yeah, okay, so maybe a couple of you. So you're familiar. So I'm just gonna be mostly introductory this time. So bear with me if you're already familiar, because it's really more of an introductory talk that I'm doing. Okay, so let me kind of get back. So I'm a developer advocate, so I go and do presentations and basically to represent the company and kind of tell, you know, share knowledge. I'm not here to make sales, but just share knowledge. But of course, I work for a company, so I do have to share with you some of the things that my company sells. But I try to share it in a way that you can encourage you to use it, because we have also like free tier usage too, that you can try out our vector database. So, okay, so that's the thing. Okay, so, but my background though, I'm more of a Java developer. I work over 20 years as a Java engineer and in different things like open source and all kinds of stuff, and I'm Java champion. I also run the Chicago Java users group too. So if you're a Java developer or interested in Java, I'd like to invite you to join us too. If you can find us on meetup.com too. So that's me, and then these are just all the things. I mostly come from more of distributed systems, but now getting into Gen AI. So I'm entering this brave new world, and it's really exciting. As we all know, ChatGPT came out, what, November? And kind of took the world by storm, right? And we all know. So yeah, so it's kind of exciting. So again, this is just more like introductory. So I hope to give to some of you who are new some overview too. But you can also help me and also suggest to me, give me feedback or ask questions too. So I like to make this more interactive, to make it more interesting too. We're all learning together. So Okay, so if I kind of look at artificial intelligence, right, I kind of like go back to some roots, get down into business. Basically, it's not just AI. It's not just like, recent years. In fact, I think if we kind of really have to think about it, you can go back to BC time frame, like 400 to 500. When I was doing research, it's interesting. The first steam-powered flying pigeon of Archytas is a Greek philosopher that actually invented it. So the idea is that why is it kind of AI kind of related? Because it deals with automation. So if you think about it, right, it's AI is helping us with more automation, take away all of the mundane things that we otherwise need to do. That's the goal. But anyway, so some kind of history first, right, as I was looking through. In the near old times, so kind of fast forward to now, or kind of the most recent full century, 20th century. So this is just like a graph showing you all of the timeline, I guess, of all of the history that recently happened. As we know, in 20th century, it was exciting. There were a lot more research being done. And it's basically also the science fiction, golden age of science fiction came out about, can machine take over all of these things? Suddenly, too, the whole human history, we're kind of going towards this artificial, robotic type of revolution, too. So, but the thing is interesting, too, as I'm thinking about ChatGPT, I mean, it's taken the world by storm, but if you think about, there's another form of early stage of kind of a chat type of artificial intelligence. I'd say it would be like using Emacs. I'm not sure if some of you might have used Emacs, the editor. There's like I think a doctor or something, right? Is it called doctor? But it's an early form of chat GPT, if you can say so, or come a chat robot, right? So you just basically ask question, and then it will answer you. And most likely it's like ask the doctor. You can say I'm not happy, and then it will respond back, why are you not happy? And then you keep saying, and then it's very kind of not very flexible type of interaction. But that was like an earlier form of kind of a chat GPT type of early form, early stage. So anyway, I just thought I'd bring this up. So it's pretty exciting, right, in all of these, but I won't go into all the details, but I will also be sharing with you this slide deck too if you want. So again, it's all about automation that we're talking about. So this diagram too is just, again, more high level describing, maybe a lot of you already are familiar with AI too, like somebody new coming in, right? And I also talk to developers too that are probably less aware of what AI, all the distinctions. So this is just a kind of the typical Venn diagram, so to speak, to describe artificial intelligence is the overall umbrella, and then inside it there's machine learning, because AI is basically mimicking intelligence, right, and behavior patterns of humans or of any kind of living entity. But machine learning gets into how the computer can learn from the data itself, a little more sophisticated. You're learning from data, and also like based on some complex set of rules too. And it is really more about training the data. There's like supervised learning and unsupervised and reinforcement learning, as you all know about that. And then of course it gets more like deeper, would be getting into deep learning, in which you're dealing with neural networks too. Is how do you learn, by mimicking how our nervous system works too. So that's kind of like set the stage in here first. And so let's then now fast forward a little bit. It's not quite like a full history. I just want to quickly touch on it. So fascinating look at the Gen AI era. So what is Gen AI, right? It's basically a very disruptive field in AI. Why is it disruptive, and why is it coming out now? If you think about it, because it's now able to change the way we create and also consume the contents too. But of course, it's as such is chat, so it's basically based on your input as some text, and you do need to have prompts, right? To kind of you have to ask questions in order for it to make matches, to give you the answers, right? Essentially, that's what it is. It generates contents based on the prompts. And as we all know too, right now too, there are new positions coming out that are actually doing prompt. How do you ask the right questions in order to get the right answers? That's absolutely important too in this new field, new subfield, I should say. So it uses a combination of machine learning as well as neural networks to produce contents. That's what it is. And it's fascinating. If you think of Gen AI, actually, before Gen AI is predictive AI that we've been doing for quite some time, right? That's more about the analytic side. And you're looking at, mostly too, I'd say the usage would be more on predictive side, right? And predictive, I mean, meaning that you're making forecasts, but the data tends to be more business data or maybe weather forecasts, so a bit more of a short-term type of use. It's more like, I'm looking at these data and then I make predictions based on some previous data, right? And you study it and then you produce some kind of prediction. Like, again, like weather forecasts, business forecasts, that type of thing. Whereas for Gen AI, I think it's more amazing because it's now able to write an essay and do some of these things that are more, so to speak, more on the kind of, business side. It's more about like arts. You can produce images. You can also like produce essays and write, a whole poem for you. Even write code too. So that's what is kind of disruptive about it. And so now, like if I go back to the new millennium, so these are just kind of key points too. 2003 would be that, the Yoshai Bengio and his team developed the first feed-forward neural network language model. And then in 2011, I think that was something that was more known was because of Siri. Siri also comes from iPhone. So Apple brings AI and natural language processing assistance to the masses by having Siri. So, and then in very soon to 2013, there's also the Word2Vec. It's a technique for natural language processing, right? That uses a neural network to learn word associations from a large set of text. So that's what in 2013. So as you can see, like in the new millennium, there's already a lot of this research doing to kind of work on the language processing side to kind of, for this field of research, I should say. And then in 2017 will be the Google researchers led by Ashish Vaswani. They have a new simple network architecture, the transformer at that time. So, oops, okay. All right, so, and then now, okay. I think before I get a little bit further too, I thought it might be kind of helpful too to kind of take a look, right? Because we have data scientists in the room and we also have engineers too. And I feel that, as I'm getting into this field, everybody's ChatGPT everywhere. But the thing is too, it might be useful to also understand there's the theoretical side of things and then also the practical side. So I feel, I mean, maybe you can correct me, or as I'm understanding more, data scientists, right, you tend to be more of like, dealing with theories, concepts, that type of stuff. So let's say here, this picture will be data scientist. It's like a computer vision engineer. And the thing is too, is that you're dealing more with the theory, what it should be, but it's really up to the data engineers, data architects, perhaps an AI engineer, and ML ops, right, machine learning operations to actually implement and make things happen too. From what I know, talking with another data scientist, he was just saying that, well, sometimes too, data scientists are not so sure how to do something. So if you can kind of think about it, it would be data scientists know what needs to be done, but then it's the engineers to know how to make it happen, right? And they are less concerned with the AI side of things, let's say, right? So you kind of look into all of these. Basically, too, you do training, right? You need to have data sets. You need to do training. You need to actually, I should say, create all of the data set, and then it goes into training, and then testing, and do all the comparison. This cycle kind of continues too. But basically, too, I just thought I thought this diagram could represent a little bit better of bridging that theoretical side with the practical side of data of ChatGPT in this new era too. So. Okay, and I do have to apologize. This one actually I found out, well, anyway, I didn't have enough time to kind of finish all my slides, so if it's a little confusing, let me know. Okay, so, all right, to kind of continue on, right, with the GPT kind of revolution. So it stands for Generative Pre-trained Transformer. That becomes like the thing now. So what is this, like GPT? It's basically, it takes prompts, right? I talk about prompts. So it takes the prompts, but the prompts can be done in human languages too, and not like in the past in which you need to maybe, ask your computer to do something, ask a program in a programmatic way. These days, you can just talk to it like you talk like between different human beings too. So I think that's what it's kind of like more like a disruptive about this. You can just take natural languages that doesn't need to be conformed to some kind of strict rules in order to figure out what to do with it, right? So that's the input. And then there's also like essentially pattern matching in there too. We talk about search, but they are called similarity searches, right? So essentially those searches are searches, but they are more about the pattern side of things that does all of the matches. And it answers questions for the prompts, right? So that's what is the GPT kind of model. That's how it works too. So it produces content such as like new essays and a blog post on new computer programming, or like writing a new piece of music. And it's just pretty fascinating. You can actually, have, make up things, right? There's also the deep fakes. You can fake some people doing something as well. So that's where the danger is as well. Okay, so now let's kind of get a bit into the GPT side of things. It's basically, it started showing up, relatively new. It's back in only 2018, right? So if you kind of look at it, in 2018, this Alec Radford wrote a paper on generative pre-training GPT of a language model. So that was so he wrote that and was republished on OpenAI's website. And it shows how a generative language model can acquire knowledge and then process all the dependencies unsupervised, right, based on pre-training on a large and diverse set of data. So that's about, if you kind of look into this, it was 2018 timeframe. But then very soon too, in 2019, OpenAI then releases the complete version of GPT-2. So that was trained on a data set of more than 9 mission documents. So it's still much less than what it is today, but then that was kind of a big kind of milestone at that point, right? And it has text from URLs shared in Reddit posts with at least 3 upvotes too. So, okay, let's see. And then, then it kind of fast forward a little bit now. So it's a really short time frame if you think about it. So in 2022, just last year, the startup company Stability AI, right, develops Stable Diffusion too. So that's when kind of a deep learning kind of text to image model that came out. And that was kind of also quite revolutionary at that time, right? And leads to the rise of different like diffusion-based image services such as DALL-E and Midjourney. It was only like a year ago. So everything's kind of changes really fast, even as we speak too. And then in 2022, that was really the biggest, I think, was the shocker, was actually November 30th, right? When of 2022, so less than a year ago, that was GPT 3.5 that got released that really changed everything. And it's just within 5 days, it reached like 1 million people. So we all kind of know about it. I think that's how it kicked off all these revolutionary time in which we are all working off and find ourselves working with Gen AI. So, okay, so it's kind of an exciting time, I should say, right? And it's actually, there's still a lot of things that yet to be uncovered, I believe too, right? And so if you kind of look at it too, then since it came out in less than a year ago, then Microsoft also integrates like ChatGPT with its technology, or actually I should say, yeah, Microsoft does it with Bing, right? They integrate ChatGPT. And then, and the feature now is available to all users too. And then Google then also released its own as BART, that's another ChatGPT that it has. And then OpenAI then releases yet another one, which is ChatGPT 4, which is like, actually, apparently it's much better than 3.5 as well. And then it also charges you some money, more money, the premium option too. And then as we talk to right now, right, in 2023, as we know right now, the researchers keep going, and we'll be expecting to see even more advanced version of ChatGPT coming out too. So. All right, so, okay, so now then let's get a bit then, I thought it might be useful to also talk about some of these terminologies. Maybe you're already working with it, but again, for some of you may be new to it. So when we talk about this field, right, it's pretty much too is relying on this subfield of linguistics, of computer science. It's interdisciplinary because it deals with linguistic as well as computer science, this NLP. It's pretty much, it's more theoretical, I'd say, in this case, right? The idea is to try to process a large data sets, right? Such as the text corpora or speech corpora too. So that's the concerned with it, and it used like rule-based or probabilistic machine learning approaches to it too. And it enables computer to learn from, all the contents, and, also to not only learn from it, but learn from the contextual side of things too, and also figure things out, the sentiment side. That's what is kind of revolutionary about it too. And the breakthrough would be to draw insights too from all of the documents, not just like mechanically translating something. It's basically go deeper than just on the surface, interpreting what it is. And then, of course, now we have large language models, and that's the thing. I think it gets more kind of down into, if you're engineers, developers, then that's the thing we kind of work with. And LLMs is like everywhere, this thing. So essentially, what is LLMs? They are a type of machine learning model, and it's what is called like foundation type of model too. And as we all know, that takes a large corpora of data. You need to process it, and it takes many GPUs, and also like takes days or weeks, or it could be months as well. So as we know, it's not something that we do ourselves individually do on a day-to-day basis. And it's basically too, what it does is it performs the NLP, natural language processing task, and generates and then also classifies the text as well. And it answers like questions like the prompts of these things, right? Just like humans. In all of these, as I mentioned too, analyze all the sentiments as well, chatbot conversations. So it's kind of revolutionary in that sense. And now to just kind of bring up some examples too of as developers or engineers, how can we work with it? Is basically you can use LangChain. I think it's already Dimitrios talk about. It's very popular too. As all the language, all the interface, you can use this. I suppose it's most popular ones right now, LangChain, but primarily still Python, and also has JavaScript. But I know too there are also other languages porting to other being ported, and there are numerous other libraries also popping up as well. And of course, like Facebook too has Llama 2. I think it came out with Llama first, and then now is Llama 2, that one too. And essentially, I think they are giving out for free, still free, I think, at this time too. And then of course, then there's also Google that has Palm, and also their Vertex AI kind of API interface. And then of course, Hugging Face too is also a very popular one that's essentially serves as like a hub for you doing all the AI, all of the things that are dealing with Gen AI too. So yeah. All right. So here too, I kind of just specifically point out the Java-based API frameworks too. If you are a Java, how many of you maybe could be Java developers here? Yeah, a few. Okay. Yeah. Okay. Cool. So maybe you can also kind of share too. But right now, just want to point out too, at my company, DataStax too, we have also a Java version of Llama. It's JLlama too. So that's the GitHub for it. Then there's also our founder of DataStax, Jonathan Ellis. He's actually working on what is called like JVector too. It's basically making use of Java 20. Like some of these Project Panama, or some of these features from there as well as I think it leverages on some of the storage attached indexing. It's actually quite sophisticated too, but I have not actually started looking deeper into it. But I just want to kind of bring to your attention if you're interested in that, because it's going to be released, not quite yet, but just want to point out to you, it's all open source in here. And then there's also LangChain, has a LangChain 4J as well. That's a Java version. Also Llama 2.java as well, and which is a direct port of Llama C, the C code too. So just thought I'd kind of bring it up. So, algorithm, yeah, they're libraries, I should say. They're API interfaces. So yeah, that's right. Yeah. Yeah, that's actually a very good question. I believe, yeah, you have to do it, yeah, in Python in that case. It's interesting. And here's the thing I'm finding. I've asked also questions about training, right? Because it's quite expensive from what I understand. Being so expensive, then people don't talk about it. You just let the big companies do all the training of the large foundation models. Is what it is, yeah. Yeah. It's super expensive, yeah, all the GPUs, yeah. Although now there's, I actually didn't. Hugging Face, yeah. Is it Java? Python, yeah. Yeah, there's Python too. Yeah, that's right, yeah. That's right, yeah. You can train. Yeah, that's right. And then of course there's also a retrieval augmentation pattern too that you can use for actually training in which we know the foundation model. You get trained. It takes so long. You only do it once and then you use it for a while. But in the meantime, there are all the changes that are happening. Then you can actually use this technique, retrieval augmentation pattern, essentially pick up data too, right? Yeah.
70 billion, and you can train it yourself. So you don't need to train from scratch. I mean, you can do a specific training, which might take only like 1 week or 2 weeks. I mean, it's still not cheap, but it's still, you don't need, I mean, it's maybe any startup.
But you still have to run a pattern.
Oh, that's the, yeah, but that's the deal. I mean, there's no the cost there. I mean, the GPUs are like $800.
Yeah.
And once you train it, then you can run it in very low power.
Yeah,
but, I mean,
that's right.
They still see when, I mean, the model is not running on itself. I mean, it's like impossible.
Yeah, that's right.
Stanford figured it out. They
Yeah.
claim they
Yeah.
did it according to cloud, claim
Yeah. Yeah.
fine-tuned it. Another LLM, they created, I think, 1,200 question marks.
Yeah.
They used another LLM to generate
Yeah.
and then use that to fine-tune
Further refine-tuned, yeah.
language.
Yeah.
Claim it costs
Yes, something, yeah.
$600 or so.
That's right, yeah. So that's essentially, I think, it's leveraging this pattern called retrieval augmentation that you can essentially help you with fine-tuning, with it. It's less expensive as well.
So Llama 2 has many people. You can download it and modify it and train it and repost it in GitHub. That's why there are, now it's kind of confusing. Maybe next time
Yes.
I will show you. Confusing because you can find 100 Llama.
Yeah, but different,
purposes.
yeah,
But
that's
the
right.
bottom line, Llama 2 is the best because it's very good.
Yeah.
And it's open source. It's a
Yeah.
MIT license, to my knowledge. So
Yes.
they still limit some. You can have more than 400 million queries per month, per day, or not exactly, but it's
Yeah.
open source. So anyhow,
Yeah, no, that's good because you work with it
so
longer than I do.
everybody here
Yeah, to do that, yeah. That's right. Yeah, these are much smaller subset. Yeah, you can do, and of course there are different industry. You have different data that you can train just for that. Yes, yeah. You can do it on your own, but like do a large foundation model, that's not possible on your own. It's too expensive. Yeah. That's right. Yeah. So that's what it is. And okay, so now I'll just move on a little bit, then talk about vector database and vector search. I think I saw just a few hands. You are already working with vector database. May I ask you which vector database are you using? Are you using Pinecone? Or anybody using Pinecone maybe? No? Or maybe some other, right? Yeah, maybe Weaviate, I think. Yeah, no? Okay, so anyway, just wanted to point out too, again, DataStax we added in vector search capability is essentially added in a new data type called vector data type. As you know, that traditional database, where like all of our storage mostly, we're working with what's a scalar data type, right? So now when we work with machine learning, it's not that simple because we are now talking about multi-dimensional data type. So we need a new technique to kind of handle this kind of data because we want to be able to do what is called like similarity searches, right? It's a contextual kind of searches. So kind of a different way of thinking, so to speak. So basically it enables to do it, you need to have a new data type called vector data type. So it actually, if you're interested in that, is essentially it requires you more interest and knowledge into more doing math. So if you say, for example, I was actually a math major, I do have to say it was interesting. I worked for so many years. I never actually make use of any linear algebra. Finally, like after 20-some years, I'm like, oh, I finally get a job that's actually dealing with linear algebra. I was asking, I remember as I was a professor, how do we use it? But back then there was no such thing. But now it is actually, I get a new sense of appreciation. So a lot of math too, if you like math, this is the right thing to do there. Matrix, dot products and all of these things, right? So, okay, so Well, that's what it is. So just quick summary, right? What is vector database? Is purpose-built database, right, that serves up this vector data type. And it's essentially for complex machine learning kind of purpose. And the thing is, too, what it is has this concept, right, of vector embeddings. And so that's the thing. Embeddings are essentially numerical representations of the data. So you can be like, kind of creating data and kind of, what you call it, like pulling in data into your storage, and you essentially, too, can do transformation and transform all your data into embeddings. So represent them in different like numbers to represent. And the idea is that this will help in the search and makes it much more faster like that. It's a special way of indexing your data to allow for fast search too. So, okay, so essentially too is a form of feature engineering, I think is what it's called. And I just want to point out too, this one technique called approximate nearest neighbor that can be used is basically like do searches too, to look for, you have, let's say a sentence, different sentences, and then you assign different numbers to all of you tokenize your string, let's say, and then you assign numbers to each one of them. And then at the same time too, you have many strings, let's say, of words, right? So actually I should have done well, I haven't got time to actually, I study it, but I haven't got time to do a proper presentation, so I apologize. But anyway, the point is that you can actually take strings of data and then tokenize it and assign numbers to it. So as you can see, if that's the case, then you are essentially comparing the distance, right, from your strings. And you can kind of do searches by, you break up all of your data and assign numbers, and then each one of them are different, and then you can basically do searches to see how far do they kind of differ from the main one that you want to search from, for example. I don't know if I make it clear, but it's a bit of a math that's involved in that. So that's basically approximate nearest neighbor. Mm-hmm.
If I open the hood of the vector database, what would I see? Would I see a sentence?
Oh, okay.
A sentence with some kind of
yeah, it's kind of an array. If you think of it as an array of floating point numbers.
There'd just be numbers.
Numbers, yeah, that's right. Is that you see tons of numbers too if you want to do like a select and that type of stuff. So you can kind of, I can, if there's time, because it's kind of running short on time, maybe I should do another presentation to show a bit more, because on Astra database, we actually, there's an example too. I'll also share with you if you like, how you can actually use like query language, is the Cassandra query language, much like SQL. You can actually do like, like a very simple searches too. I can kind of show it to you how it looks like, for example. Yeah, yes. Yeah.
Those are static, right? Regardless of what that doesn't change as
Oh, I see what you mean. Yes, that's right. If you are kind of working with certain document, then once you kind of save it, that embeddings, it will be there. It's if that's what you're asking, they're not dynamically. They won't change once you.
It doesn't change as the map.
The map is. Yeah.
The database will always have static.
That's static. Yeah, that's correct. Yeah, that's right. So yeah, okay. So I hope it's. Sure. Data embedding and text embedding. Can you explain your referral to text? In what sense of text I want to understand? Because otherwise we're talking about vector embeddings in here. These are just, like I said, vector embeddings are different. They are more floating point numbers that represent that particular string. For example, the tokenized. Oh. Very good question. Anybody knows? Maybe text versus vector embeddings? Yeah. Are they the same? Referring to the same?
Embedding of text in terms of vector is the same thing.
That's what I would think. I just want to make sure too. Like, is there text embedding, vector embeddings? Yeah, maybe. Yeah.
Word embedding.
Yes.
So you start with a text sentence or a word or doc, and then you transform that into a vector.
A vector number.
What is called.
Yeah, that's correct. Yeah, exactly. So, yeah, let me just kind of.
The thing about this, I think, is that the input necessarily doesn't have to be text. It could be like mathematical
Oh.
equations, or it could be something else. As long as that mapping exists.
Yeah, that's right. Yeah.
It's a fundamental assumption.
Yeah.
That is, say that the world is a finite dimensional system. It's not.
Embedding dimensions is finite.
The world is not a finite dimension. But this is as good an approximation as there is.
Yeah.
So there is a theorem that says you can approximate an infinite dimensional space with a finite dimensional space as closely as you wish, but you have to throw your hand as much as you can. So
But your question is different, right? Like you were trying to ask about the embeddings.
Yeah, I was trying to clarify, like what, like how do you relate the text
An embedding. Oh, okay. I think if that's the case, it's more direct kind of mapping because you're breaking up, let's say, a sentence. You're breaking up there, say, we are at the meetup, and then Ron is at, at the meetup. So different.
So one thing I don't understand that, so like if you start with the text, right?
Yeah.
You first split it up using a program.
Yes.
And then, so what that does is that you get a set of tokens.
Yes, that's right. Like numbers. Yeah.
Each token, then you get an embedding for each of those.
Oh.
Or that's
Yeah.
what I don't understand is that let's say that you start with a paragraph. Do you get an embedding of that entire paragraph, or do you get embedding vectors of its component?
Embeddings of his component vector. Yeah, I don't think. Yeah. Vector. Yeah.
Anything what we need to be two kind of values to an item have a value. Or you can derive two dimensions. That's a vector. The value vector. It can be a word, a sentence, whatever it is. Once you keep that number, then you can see how far is that number from another number in that string.
Yeah. Yeah, it's a matrix. Yes, that's right.
So embedding is not a matrix. It's a one
It,
times the dimensional vector. It's a row of numbers.
yeah, if you kind of think of it like that, yes, when you break it up, will be like an array. Think of an array, a one-dimensional kind of array. Yeah, like that. Yeah, floats. So. You have a vector of from your database. Yes, yeah. If that's what you.
So I think
Yeah.
so that because these are vectors of
Yeah. That's right. Yes. Yep. Yes. Yeah. That's what it. Yeah. From that, yeah, it does. Yes. Yeah. That's right. Yeah. That's right. Mm-hmm.
So each of those would have well their floating point number. The way it looks up the data because it has integers, and then it will look at those
That's right.
integers, and then it will try to retrieve that relevant mapping
Yeah. So.
But as far as the vector embedding, the vector database, the data retrieval, I believe that happens with less.
Yeah, that's right. And also too, you can actually when you do like say on Cassandra there, you can actually do your select, and then you can also say, you know, how far is it? Like what's the percentage of essentially deviation from the, you know, what you're looking for, and then how far do you actually want to search, right? And something like that. Essentially, yeah,
Right.
yeah. So
It's multiple dimensions.
multiple, yeah.
Well, I've also seen videos, or one of them being from DataStax as well.
Oh, you saw? Oh, good.
It says that
Yeah.
essentially it's looks for proximity.
Yeah,
based
that's
on
right.
some score in multiple
Yeah,
dimensions.
that's right. Yeah.
So, and then it'll just look for that score that is
That's
closest.
yeah. That's essentially how it is. But let me come back here, and then we'll do a bit of a deep dive. Yeah, I feel a little bit like, you know, we're in a hurry today. So, but again, just wanting to kind of raise an awareness level of this new kind of concept, and it's very important, as you can see, right, in machine learning too, because it really enables you to search really fast. Otherwise, too, if you think of you have to search all of the strings, you know, one by one, it's going to take forever. So that's why this particular approach of vector, they're all converted into floats. It's super fast too. So yeah, but that's kind of summarizing for you. So what are vector embeddings being used for? Essentially, you know, good for doing search, right? You rank by the relevance to some query string that you're trying to look for. And also like clustering, like where text strings are grouped by similarity, recommendations, and anomaly detection too. You can also kind of use that too for that. And diversity measurement classification too. So this is kind of an important, rather important like subfield kind of in this space too. So yeah. So like I said, I can come back and do another deeper dive into this too. Okay, so, oh, this one actually, I don't know why I do this. I think this, I didn't have time to do it. Okay, so because I'm running kind of low on time, because Bill told me to do something like 20, 25 minutes, so didn't prepare as much, but I just wanted to point out, right, the benefits too. I was just gonna say Gen AI benefits without a doubt, everybody know. It's like you ask and then you shall receive, right? You always will receive something, is work being done, right, for you by the bot, and so it's much faster too. But then just want to remind you then there are also challenges too, right? And it's not just like all right. Then how can you ensure that, you know, it is correct, right? So that's where kind of the challenges are, right? Partial list of some of these issues that we need to be aware of with ChatGPT, because there are hallucinations. We kind of brought it up too, and essentially too is yes. Not really. Actually, that's a good question too. I think, you know, ultimately, I think it means that hallucinations is kind of coming back something that isn't right, essentially, isn't right. That's what it is. So, but also too, it depends, right? Hallucinations can happen if you are not asking it correctly. So the prompts are also responsible for what you get back to. So that's another aspect of it. And well, I guess not only that, sometimes too. Sometimes it's actually, I should cite you some example. Okay, so for example, I actually was asked to present, well, that was with my streaming. I was working with Kafka something. So doing a presentation for a Japanese meetup group. So the Japanese, they don't quite understand English as well. So they said, can you do it captioning in Japanese? I said, okay, and I used the Zoom. Zoom actually, you can do recording and you can do captioning. So I did it in Japanese, but there was no way I could figure it out. I believe they must be using some kind of AI kind of technique to do it. But the thing is too, it's funny, and so I passed it on the recording over to my colleague in Japan, and then he was laughing. He said it was completely wrong. And the reason is that I was doing presentation in Kafka in which they're actually, the engine, the model doesn't already have all the technical knowledge, but instead of telling you I don't know, it just comes back with some random selection of things, and so it came out all wrong. Like you try to say something, it said the opposite. So, but anyway, so my point is just saying is that, you know, that's also hallucinations essentially. But I believe the newer versions of GPT is better in terms of it might tell you, okay, I don't have the knowledge to tell you if you know what you're looking for. So I think that's an improvement. Yes. Yeah.
Related to what you just said, so let's say that you have a pre-trained model like
Yeah. Yeah.
How do you have a sense of like how easy it is to allocate a pre-trained model like that with
Oh,
your
like a new. Yeah.
specialized knowledge so that you don't
You don't lose. Yeah, I don't think you can do like fix, so to speak, or patch your pre-trained models, their foundation models, very expensive. I don't think you can. However, there's this retrieval augmentation techniques that you can use. Yeah, RAG, right? They call it, I think retrieval augmentation generation. Yeah, this particular technique, you can actually use it too. Is essentially then you can feed in some data, like there's like a subset of some data that you want to kind of help to patch it up, then you can train that particular set. I think like we talked about earlier too. You can augment, you know, your existing data with that extra set of trained data. So it will be cheaper too because it's smaller subset, maybe of some specific, say for example, I was doing Japanese language translation, you can kind of feed in that and with the Kafka data, maybe then it will generate better results for you in that case. So. Yeah, that's right. Yeah. Yeah, you need to go. Okay, thank you, thank you, thank you, thank you, thank you, thank you. Okay, thank you. Yeah. Yeah. It, yes, it can. It comes back. Yeah. Yeah, it might be. Yeah. Yeah, that's right.
And it's like 60% correct. But if you train that model with a newer version of data that has the right English to English to Japanese pairs, then it would be 90%.
Yeah,
so you
true.
would never get 100% accurate. But if you train the model, if you retrain the model with the right amount of with the right set of data, your base accuracy will go up.
That makes sense. Yes. Yeah, that would be. That would be. Yeah, that's it. Yeah. Yeah. There, yeah.
So how do you determine, okay, this question we asked got this answer. What's the data set? Train model giving that answer. Right? So that is the traceability back, which is the problem.
Just see the result.
So you can see
Yeah.
the results. You can tell
Yeah.
who is an expert, say in Japanese. This is garbage.
Yeah.
This is a good practice.
That's
You
right.
can't make determination of cost of data.
You can't have a mathematical
Shut it unless it's
back the answer.
And this, yeah, that's true. Yeah.
Right.
Yeah.
You can not have a mathematical proof, but if your original data does not have any
Yeah, but how do you determine that? Because you're getting a model.
well,
You're not getting the original data.
well in this
And there's no
well, in this case it's human. You take human intervention.
Yeah.
In this case, we knew that that the original data did not need
We don't know.
Well,
You
yeah.
how do you know unless
Yeah, yeah, you have some, yeah. Yeah, yeah. You have a question too? Yeah. Yeah. Into the vector search, yeah, I believe you should be able to. Is that correct, Dimitri? Yeah. Okay. Oh, I see what you mean. I, yeah, yeah, yeah. That's right. I think it's to improve. Probably it's like reduce hallucinations, right? In that case, and kind of improve accuracy. But actually, one thing I've been kind of interested. I read about this or went to a talk. They actually, have you heard of semantic web, knowledge graph? Actually, they believe because knowledge graph is like another way of you storing your data. It's in graph, but knowledge graph. I think they believe that they can actually be used for reducing hallucinations because they are having all of these data and they build out the relationship graph to it. So then that will kind of increase the accuracy of your data. Each thing comes back, it has some relationship you can check too. Kind of helps you with fact check. So that might be also another techniques. But I haven't found enough data, kind of information. I just saw somebody did a presentation. I thought, oh, that's interesting. That might be used too, maybe with a vector search and then combined with a knowledge graph to improve accuracy,
exactly
right?
the route we were taking before.
Yeah.
But before this whole ChatGPT and
Really?
So I don't know what happened to the knowledge graph picture.
Oh, yeah, in this new thing. Yeah, that's right.
So, and
Yeah.
it is similar to what you're saying about vector databases. So
Yeah.
there's a difference.
The difference. Oh yeah, that's right. We should talk more about it. It is a very fascinating. I think it's being so new that's it's just still being.
But knowledge graphs maintain the relationship.
But that's what the difference is. So.
Storing flows, right?
Yeah, exactly. So it's more, I guess, more flat. I think now that we talk about it, flat. Doesn't have any relationship. It doesn't show you. It's not a graph, kind of thing. So yeah. Implicit. No. Yeah.
This probably, I have no idea.
Yeah. Okay.
What I was trying to say is the graph relationships, they aren't stored explicitly.
Oh.
There's no structure
That's right.
That, this is my query, and these are its nearest neighbors.
Yeah.
The nearest neighbors are determined by the implicit nature of the data, which is the
Oh yeah, the embeddings, the deviation. Yeah, that's right. Yeah.
So the nearest neighbor actually gives you the probability of
Yeah.
how close it is.
Yeah, you to the
yeah.
yeah.
Basically,
Yeah.
So basically, if you're saying
Yeah.
trying to correct your work, right? So someone mistyped. So that'll help. Right?
That's true. Yes, you can do that. Yeah.
So if you have a bird say
Yeah.
graph, right, and if you have misspelled it as
Yeah. Yeah. Yeah.
those vector representations
Will be wrong. Yeah. That's right. Yeah.
And you can get the nearest neighbor
Yeah.
pointing to and
That's
But
right. Yeah.
you haven't calculated. Like you won't say
Yeah.
that like this node nearest neighbor.
Yeah.
You
That's right.
haven't calculated.
Yeah. That's right. Yeah. All right. Well, I realize yes.
Can you talk a little about the index of the vector database? How does the tree
Oh. That's a very good question too. I think actually we have I believe we have some articles that talk about it. Can I get let me get you connected. I'll send you some, yeah, okay, yeah. There's actually a lot of things in here that I'm just getting the service, yeah. All right, and it's getting late. Maybe I'll just, yeah, all right, yeah. Maybe I'll, yeah. All right, yeah, it can get into a whole night of description, but yeah, I should definitely schedule another one. I'll tell Bill, yeah. But anyway, so maybe, yeah, sorry, but no, that's very good. Discussion. I think it just means we should. Yeah, what is next? What's next? I should really drill down a bit more into this vector database. Maybe I'll find actually my colleague. It's actually Patrick McFadden, and the lead of my developer advocacy. There's only 4 of us, but anyway. But he's very deep into Cassandra, and he's now also talking about this too. I should actually see if he can come. A presentation as well. That's right. Yeah. We will. Yeah. I can also do one. Maybe. Yeah. And also, actually, there's also another thing I want to talk about. Maybe eventually too. Maybe another few months down the road, I can do something called Langstream that we develop. It's open source library, but working with event streaming, we plug in like Kafka to feed in the retrieval augmentation pattern. So then you can actually, like I said, there's some data, you can fill in the gaps, right? Kind of like foundation model, it's not enough, you can actually feed in this data. And we build pipelines too if you're working with event stream, like with Kafka, essentially, we have that. So anyway, but that will be further down the road. Yeah. Anyway, so let me kind of quickly finish then. So besides hallucinations, then it's also, of course, ethical concerns too. I think we have to be careful because, now you're able to do all these generating things, based on all these data. And how do you know it is true? Right? We have already seen, right, that you can actually generate maybe the Pope's face and saying something wrong and that type of stuff. So the thing is too, sometimes we may not be intentional too. So I think it's very important we have to think through this, and then that's why a lot of governments these days are like very hesitating of allowing this to to be used, because you can create a lot of issues from it too, and could be unintentional too. Like any kind of malicious thing can be unintentional. So we have to be very careful with it. And then also, again, right here too, I also mentioned about real-time, up-to-date data, because we are just relying on some foundational model which has been pre-trained a couple months ago. Something happens between then and now. That kind of real-time type of data is still kind of, we're still trying to figure out too how to do this in real time kind of thing. So, okay. And then, okay, so I probably don't have time today to show all the demo, but maybe let me real quickly too, just show you this thing. So if you go to Astra, it's our managed cloud platform for the vector. Astra database is our managed Cassandra that has the vector search in there. So just wanted to share, and I also will be sharing with you my the slide deck that has all the links too. So I'd like to invite you, because every month you can get $25 for free to use for personal development. Use this database. So when you sign in too, we don't ask you for credit card. That's another nice thing too. Then we don't bother you too much, right? So yeah, I like that kind of stuff. You get it for free. So in this case, I already have a Google account. Let me do it again. Timeout. Okay, and I do it in there. So I just want to quickly show that to you, and then you can sign up for it. Try this out, right? So okay, so it brings you to our database, the console there, and then you can actually go to the left side database, or over here to vector search is now production ready. You can just quickly create a database. You can create regular serverless database or a vector database. So let's say I do a vector database. You can say, okay, this is AIChem. Let's say Chicago cheese, like that, and then you can say Chicago, and then Google. Right now, I think it's only Google Cloud at this point. So, oops. Oh, database. Oh, database limit reach. I think because I already have too much. I didn't know they give me. They didn't used to. So okay, but anyway, let me quickly show you then. In this case, I have something already created, so that's not so bad. So I have this one called like a test kind of vector database, although it's showing it's vector enabled database. So when I talk about you can try things out, is going to this CQL console there. Is you can kind of use SQL syntax to interact with your database. Such as over here, you can do like select. Actually, what database? I forgot to actually. Is it called product? Actually, is it called test.product, something like that? Oh, okay. So I forgot exactly what this is, but unfortunately, because I didn't, yeah. Again, I was trying to set things up, but today I just didn't have time to double check, so I apologize for it. But the idea is that you can actually also try this one thing out, which go back to the overview. There's a quick start, just wanting to bring to you too. So that's right. So over here too, you can also sign in and then get into the quick start, and then it helps you with Q&A search with LangChain. There's also, where is it? Examples, yeah. So if you also click on the left side, there's Astra Vector Search. There's examples. If you click on there, you can also try things out. There's the retrieval augmented generation for AI chatbots. We have some example there, or image search, all of these, and then also query vector data with CQL. This one I can recommend you to try it. And so we have kind of Huh?
30 days?
No, no, you mean this one? No. Oh, this usage? It is free, $25, up to $25 per month of usage, yeah. Yeah, well, and you can, of course, give your credit card and then use it too. But the thing is, because you come to this talk, I can also help you. If, let's say, you are working on some project, maybe for your business, a startup, we will be happy to help you too. Actually, my company can give you extra credit too. If you have kind of projects you can prove that you're going to use for your business. So yeah, but otherwise you get $25 per month. If you're just using for personal projects, it's actually quite enough too. Yeah, yeah. So, but otherwise, then every month you get a refresh of another 20. Yeah, for small personal projects. Yeah, that's right. Yeah, yeah. So it would be good to try things out. Right? Otherwise, everything else costs more money too. So over here, but I just want to kind of point out, you can kind of follow along this example, and then how do you set up your database? How do you create a table? Things like that too. But I just wanted to point out, right? For example, do similarity searches. So if you're asking about these things, you can actually take a look at like some of these examples will show you how you can work with vector database, all of these things in here too. So yeah, but I know that it's already past the time. I think we're supposed to end at 8 o'clock. So, but because of all the delays, so I don't want to further delay you. But I just want to maybe point out to this gentleman here, you were asking all of these things. So you can kind of, for example, you can do select, this one here, vector search. Let me kind of increase. Yeah, so you can actually select, right, let's say from a table, this actually, you can do order by item vector. ANN stands for the approximate nearest neighbor. And then you can essentially do it like this. It's kind of a raw way. You can kind of, approximate nearest neighbor of all these vector kind of, numbers to kind of do your searches like that too. So yes. Yes, that's right. Yeah, that's what it is. Is each word in that too. So, like I said. I'm sorry, you saying?
Each vector is representative of a word instead of a number
in the yeah, I guess yeah, I think so. Yeah, okay, yeah.
So that vector there, it probably represents a word or a sentence.
That's right. Yes, yeah, that's correct. Yeah, yeah. We can kind of also take it offline and talk some more about it too. But yeah, okay. So in other words, just wanted to quickly show this to you. Then if you want to get into, roll up your sleeve, get something, try it out. This will be a good way to help you to start learning about vector database. And then also I kind of brought up too, there are other companies doing vector database. I should say there's Pinecone and Weaviate. I think those seem to be the bigger names, but I think they're good in their ways. So they actually have a lot of training materials, but I have to say too, Cassandra itself, the Cassandra itself is so robust. Actually, if you're working with enterprise products that you need to have scalability, I would think ours would be a much better choice than the others. So yeah, so something just thought I'd share with you too. So, okay, and where is I have to go back to here. Okay, all right, so since it's kind of getting late, just want to quickly share with you the resources. And if you like this slide deck, because I have some information or other links to, this is the slide deck. And yep, okay. Okay, and okay. Okay, all right, yeah, thank you. Yeah, thank you, really appreciate, yeah. And some more, yeah, if you take this slide deck too, there's also the middle one, the astra.datastacks.com is our managed cloud platform that you can try things out for $25 per month or more if you can need it more too. So, and then the rest of all these things are in here. And then, there's also, actually, okay, so this is the same thing. You can sign up also using this link as well. Yeah, yeah. This one's actually, I do have to say, it's our marketing department gave me this. I almost forgot I have to put it in here. So yeah, you can do that. And then also just to let you know, myself and another colleague, Aaron, who lives in Minnesota, we've been doing this weekly podcast too that we broadcast on Tuesday at 1 p.m. like Central Time. So it's streamed to YouTube and LinkedIn too. We just normally talk about 20 minutes of interesting news, or so far we've only done 8 episodes. But let's say, for example, we're talking about Cassandra IO, this particular library that works with LangChain, and it's from one of our developers too. So, and different things too that we talk about. So yeah, so that's that. And then I also have my Twitch stream. If you want to follow me, it's here. And I try to go back to doing more live streaming at some point. And then my DataStax offerings, just want to point out, we have EstraDB with vector search. And then also we have a company we recently acquired 6 months ago called Cascada. They have like real-time AI, a bit more on event processing with time series kind of data too. And then also I mentioned to you about Langstream is our event streaming, the RAG pattern library too. And then also, this is the fun part, is that there's a conference called GoTo AI Chicago. But they actually were running just GoTo Chicago. Maybe some of you are aware of it. And then for the first time, they are doing an AI-focused conference, and that will be on October 23rd to 25th. So that's the link. And they just gave it to me, so I quickly added it in. And this is the AI Camp 10 is the discount code if you want to go attend them. So also, too, we are doing one raffle for a free ticket, too. I don't know if you have time, folks. Oh yeah, the AI camp, yeah, is case, that's how they gave it to me, so it is case sensitive. And I was gonna say, if you want to stay behind and get a free drawing of 1 free ticket to attend, and it will be in Convene, which is like by the Fulton Market, right around near Google. That's where the conference is. So because they just gave it to me, all of a sudden I'm thinking, I actually have a form. Let me give that to you. Okay, so this is about me too before I go. My LinkedIn, my Twitter, or X, I should say, and then my Discord channel. I have a Discord channel too for if you want to ask more questions, and it's easy to get a hold of me there. And then, like I said, I wanted to ask who would like to enter into the drawing of the GoTo AI days. Yeah, okay, so how would I do it? You know what I'll do? Because yeah, everything is kind of like such a last-minute thing. I got too many things going on. Let me do this first, and I will bring up a this thing. And oh, sorry, I know I'm keeping you so late. So, but that's your reward for staying late. You are eligible for the raffle. Yeah. Okay. I'm just gonna do this one thing called Wheel of Names. Yeah, you know that, right? Yeah, okay. Let me do that. Okay, so maybe you can tell me your name, and we can do a drawing in here. So one ticket, yeah. Okay, and you can tell me your name too. Narendra? Yeah. N-A? R-E-N? D-R-A. Narendra. Okay. And yours is Gregory? Okay. Gregory. Gregory Primmosh? Okay. Yeah, you can type too. Umar? Okay. Okay, Lif is your name. Okay, got it. Yeah. Okay, and then yours is David Allen. Okay.
Oh, there you go.
Okay. And Mikhail, right? It's called Mikhail. I know Satu Marzek. And hold on a second, Magdalene. Magdalene. I'll just say Magdalene. Okay. Shobana. Yeah. Yep. I have a friend is Shobana. Okay. And Kyle. Okay. Kyle. G. Yeah. Okay. Cool. And Naveen. Okay. Oh. Naveen. Okay. I have your identity. Seisha. Okay. Yeah. You're welcome. Okay. And oh, thank you.
G hit you, that would be fine.
R-A-G. Reg. Okay. Reg.
G hit you.
Oh, I'm sorry. Oh, yeah. Let me do that. H-U and Raguna. Raguna. Okay. Yeah. S-U-H. Sue. Yeah. Okay. Thank you.
Hi, my name's
Harper. Harper. You're welcome. Sang. Okay. Yeah. Okay. You
I'll send you a LinkedIn.
yeah, please do. Yeah, let's stay connected. Yeah, okay, that's cool. Okay, yeah. Anybody else wants to be in this drawing? Yeah, we have these names now. Yeah. Okay, Zhao. Sure, sure. Yeah, let me also enter Zhao. Okay, and then
John H.
John H. Okay.
Not too many Johns here.
Yeah, I'm surprised. Yeah. Oh yeah, that's right. Sakshi. Okay, Sakshi. Okay, and then